Have you ever wondered how containers or container technologies such as Docker work? Well, before that, what exactly is even a container? A container is just another process. As the name indicates, it happens to be a process that is contained, isolated in certain ways. In what ways? This is best illustrated with an example. To do that, we will have a simple story, a made-up one, in which we have 4 characters. We have Alice and Sam, who are book lovers. We have Connie and Brian, who are fitness enthusiasts. Since Alice and Sam are Harry Potter fans, we put them in the group of Potter fans. Since Connie and Brian are fitness enthusiasts, we put them in the group of fitness fans. Now, let us assume that all these 4 characters are checking into a resort, and our challenge is, how do we isolate the Potter fans from the fitness fans so that they do not bother each other? That is, we are going to isolate the Potter fans, and we are going to isolate the fitness fans. How do we achieve this? We are going to achieve this using a kernel concept called namespaces, which is at the core of containers. Now let's go take a look at how we can make this happen with namespaces. So what I have here is a setup for our story. That is, I have a space for the Potter fans and a space for the fitness fans. What I'm going to do now is start a process, one for each of our characters, Alice, Sam, Connie, and Brian. And what I'm going to demonstrate is that Alice and Sam, the Potter fans, will have no idea about Connie and Brian, the fitness fans, and vice versa, even though all these processes are running on the same host. And I'm going to do that using namespaces, a specific type of namespace called the PID namespace. But before that, let us demonstrate the problem. That is, let us start these processes without using namespaces and see what happens. So in the Potter fans window, I'm going to start Alice and Sam. And likewise, in the fitness fans window, I'm going to start Connie and Brian. Now, what these processes are doing does not matter. These are just dummy processes. They are just sleeping behind the scenes. The key to understand is that there are 4 processes running on the same system. And the fitness fans would have created a text file called fitnessfans.txt. And what I'm going to show you here is that Connie, that is the process called Connie, is able to find the process Alice. So if I go back here and if I do a PS, you can see the process ID of Alice is 7086. So what you see here is that the process Connie is able to find the process Alice. And likewise, if you open the file created by the Potter fans, you will see that the Potter fan Sam is able to find the fitness fan Brian. So I come here, I do a PS, you can see the process ID of Brian is 7100, and that is what Sam is reporting. So the key here is that the processes are able to find each other. Specifically, the Potter fans are able to find the fitness fans and vice versa, which is what we are trying to avoid. So how do we solve this problem using namespaces? That is what I'm going to demonstrate next. So before I do that, what I'm going to do now is just kill these processes here. Likewise, go here and kill these processes here. Great. Making sure all the processes are killed. Great. Okay, so using namespaces, specifically the PID namespace, I'm going to demonstrate how we can isolate the Potter fans from the fitness fans. So what I'm going to do now is start a namespace. A namespace is essentially an isolated environment, and the command you use to create that isolated environment is unshare. As you can see, the name unshare indicates that I want to create an environment that I do not want to share with my parent. That is what the unshare command means. And the specific type of namespace that I'm going to create is the PID namespace. And what I'm going to do is start a new process in that new environment. And do not worry about this command. I will explain this in detail in another video. And then what I'm going to do is start this in a new bash shell. And before that, I need to be sudo to do that. And I enter password. And as you can see, we are now in an isolated environment where we are running as root. And likewise, I come here, I do the same. I'm creating a new environment, a specific type of environment that would let me isolate processes. That is what the -p is for. And I'm saying create a new process in the new environment. Do not worry about this command, this option at this point, and create a new bash shell. And again, I've created a new environment. Now, in this new isolated environment, let us go ahead and start our Potter fans. Likewise, Sam, come here. Let's start the fitness fans, Connie and Brian. So all the 4 processes are running now. So now if I open the fitnessfans.txt file, let us see what these processes are saying. Are they able to identify? Are they able to find Alice or Sam? Oh, you can see this time around, Connie is telling Brian that she could not find Alice. And likewise, when you go there and when you open the file created by Potter fans, you can see Sam is happy and he's letting Alice know that he could not see Brian. So what we have achieved here is that the Potter fans and the fitness fans could not find each other. Of course, the Potter fans are happy about it, fitness fans not so much, not our problem. But what we have demonstrated here is that we were able to isolate 2 sets of processes, even though they are all running on the same system. And this was our goal, mission accomplished. What I just demonstrated using PID namespaces is fundamental to containers and container technologies such as Docker. But in addition to the PID namespace, there are other namespaces that enable containers. For example, what if we want to ensure that the isolated process has access only to certain set of files and directories? What if we want to make sure that The isolated process has minimal networking capabilities. For example, it should not be able to access the public internet. How do we achieve that? For each of these, we have a specific type of namespace, and all these namespaces combined together are what enable containers. If you're interested in seeing all that, hit that subscribe button so that I know you're interested, and I'll be happy to go deep into the world of containers.